physical quantity and measurement. All right, so under this topic, there will be 5 subtopics. These topics, I'm going to highlight which is important, which is going to be the standard length, mass and time, which is very easy. And afterward, conversion of unit. Uncertainty is not really that important, as well as vectors and their properties. So these 3 are the main subtopic that you should learn so that it helps you to understand the next chapter. All right, so we proceed to 1.1, which is standard mass, length, mass, and time. So in the field of mechanics, you will be using these 3 fundamental quantities, which is going to be the length, the mass, and the time, which is rather basic. You measure the length, the mass, and the time, and then from these 3 fundamental or basic quantities, you can derive other quantities as well. For example, you can calculate the speed, the acceleration, the energy, power, and so on. All right, so the unit we use here is going to be SI unit, which is System International Unit, which was agreed in 1960 by an international committee, and it will be the main system of unit used throughout the entire course. So with that, firstly, we take a look at length. It is important to know that you are using meter instead of the prefixes. For example, kilometer, centimeter. Whenever you want to use the value into the formula, always change it to meter. All right. So regardless if it is given in the question centimeter, you have to change it to meter. Moving on, afterward, we have the mass is going to be in kilogram. All right. So kilogram is going to be the unit for mass, and then the time is going to be in second. And sometimes in the question, you may stumble upon the time given in days, in hours, or even in week. So always change it to second. So we know that 1 minute is equal to 60 seconds, and then 1 hour is equal to 60 minutes. All right, so this is what I mentioned as prefixes. For example, if we have meter, and then we stumble upon a very large value of meter, which is normal. For example, when we travel, we use kilometer. All right, so when we have kilometer, meaning that it is 1,000 meter. All right, so K is going to be the symbol for the prefix of kilo. It can also be in terms of other unit as well. For example, it can be in kilogram. All right, so we have 1,000 grams. So that is the usage of prefixes to actually simplify our writing. Okay. Yes. Fahad, do you have any question so far?
It's okay, sir. Everything will be clear.
All right. Okay. So it is important to know the prefixes. So normally what we're going to be actually using is rarely in nano or micro, but mostly in centi, as well as milli, as well as kilo. These 3 are the most important. Okay, so as mentioned, first one is millimeter, or it can be written as mm, which you normally use. Okay, and then we have centimeter, which is used to measure our height, our body height. And then kilometer is to measure distance traveled by a car. All right, so again, if we recall back to the notes, the length should be in meter. So what happened is actually always change this value in prefixes into its exponent form, okay, or scientific notation. All right, so moving on, we have significant figures as well as decimal places. So significant figures refers to the number that are non-zeros, and then sometimes zeros can also be significant when they are placed behind the non-zeros value. but 0 can be not significant when they only locate the decimal point, which is placed in front of the non-zero's value. Okay, so for example, if I have this value, all right, so the value is 0.012, and then maybe the unit is going to be in meter. So right away we can see that actually we only have two significant figures, all right, so, or 2SF, two significant figures, because 0.0 in front can be neglected when we write down this value in this form. So since you have no the prefix for centi, so for centi it is going to be times 10 to the power of -2. We can write this down as 1.2 times 10 to the power of -2. This is scientific notation, and then we can change it to prefix, which is 1.2 cm. So throughout this entire page here, we have three ways in order to describe the scientific notation or describe the length in meter. All of this, we have 1 and 2 significant figures. Same goes to the second form, which is scientific notation 1.2, as well as 1.2 cm in the prefix form, scientific notation, and then this is going to be in prefix. All right, so moving on, afterward, we have this question, which is actually inside of your tutorial. So you can take a look in your tutorial in the Moodle. So under physics and measurement, all right, so this is going to be the question for chapter 1. This is taken from your reference book, and the final answer is at the very large page. Sorry, at the very end of the text. Okay, so with that, we're going to go through this question. So as you can see here, the standard kilogram is platinum iridium cylinder, and given the dimension 39 millimeter in height and 39 millimeter in diameter. Question asks, what is the density of the material? So to calculate density, we're going to be using this formula. So we're going to be using this formula, which is rho, or the formula for density is equal to the mass over volume, m over v. Okay, so we can use this formula to calculate density regardless any shape of the object. However, in this case, we have in the shape of cylinder. So to calculate the volume of cylinder, we use this formula, V is equal to pi r square L. And then because the question gives us the diameter instead of radius, so we know that diameter will be twice of radius. So if I can show you the cross-sectional area of a cylinder, so imagine this is a cylinder very long. Okay, so what happens is actually we're going to have radius. So this is the radius, and then the radius is actually from the center to the outer end of the curved side of our cylinder, or the wall of the cylinder. However, diameter meaning that it will be twice from one end to the other end, so that will be the diameter. So as you can see, the diameter will be twice of the radius, so we can rearrange r is equal to half of diameter. So we can substitute into the formula. All right, so this is our formula. So substitute it into the original formula to calculate the volume, and then afterward give the power of 2 inside of this bracket. So we're going to have d squared, which is given by this formula, as well as we have to give power to the denominator 2. So it will be 2 squared, or it is equal to 4. So this is going to be the formula to calculate the density of our cylinder in a form of diameter. You can still use the first formula, but remember to divide the diameter by 2, because the first is actually using radius. So moving on, substitute into the formula, which is the denominator or the volume side, and then substitute and then rearrange the formula because we have double denominator here. So 4 is going to be above here, 4m over 4 pi d squared over L. And then now we can substitute all of the value. We know that the mass is in kilogram, 1 kilogram. So substitute 1 kilogram. And then we have the diameter, the diameter squared. And then we also have the length. So substitute, and then remember everything must be in standard unit, and then given here is millimeter. So we have to change to its SI unit, which is supposedly only in meter. So what I've written here is 1 millimeter is equal to 1 times 10 to the power of negative 3 meter. So substitute it, and then afterward use your calculator to calculate. And then we stumble upon a very large number, 21,464.28 kilogram per meter cube. So you have to reduce the significant figures to the reliable value, because currently from your calculator we're going to have around 7 significant figures. So we have to change to 2 significant figures, because all of the given value or parameters here are in first one, 1 kilogram is 1 significant figures. We also have diameter, 2 significant figures, as well as the length or the height is in 2 significant figures. So we're going to be using 2 significant figures for our answer, which is going to be 2.1 times 10 to the power 4 kilogram per meter cube. All right, so that is how you solve questions related to significant figures as well as the standard of unit. Okay, so this question is placed under tutorial question number 2, and then I've created a video on this separately, which is last week. So you can view the video and then solve the question for question number 2. All right, so moving on now, we're going to take a look at the next subtopic, which is uncertainty in measurement and significant figures. So the first is experimental uncertainty, which is there will be 2 here. And then we have the accuracy and precision. All right, so it is very important to report your answer or report your data analysis in a very high integrity way. And then in this case, what we have to learn is actually know how to put in our uncertainty. So we use these 2 rules, right? So if it is multiplied or divided, so we have 4 mathematical modes. So we have multiplication or division. We use number of significant figures. And then when we have addition or subtraction, all right, so we use decimal places in order to write down the final answer. So when it is multiplication or division, we use the smallest number of significant figures. And when we add or reduce, subtract, we use smallest number of decimal places. Right, so with that, we have this example. So if you are given this data, the mass in gram, the diameter in cm, and the length is in cm, and then let's imagine the question asks you to calculate the density in gram per centimeter cube, meaning that there is no need to change the unit. But supposedly in SI unit, the unit should be in kilogram per meter cube, just like what we did in tutorial question number 1. So as you can see, our final answer is in kilogram per meter cube, which is the standard SI unit. All right, so here the question requires, or example here requires the student to calculate the value as it is, which is in gram per centimeter cube, and then everything is given in gram as well as in centimeter. So the question asks for density of a metal cylinder, which is almost the same as our tutorial question just now. So the most important part is actually because the data have, in this case, uncertainty, right? When we deal with measurements, regardless the mass, the length, and the time, we always have this uncertainty, and it can be caused, for example, if you read or viewed the previous video separately about uncertainty, it can happen because of, for example, parallax error, which is position of the eye, how we measure the object or the given parameters. With that, let's imagine the smallest scale to measure the mass is 0.1 gram. So the mass can be either 75.7 or 75.5 gram, because the smallest scale is 0.1 gram. So we have this uncertainty of 0.1 gram. And then for the diameter, we have two decimal places here, which is plus minus 0.01 cm according to the meter rule that is actually being used. All right, so moving on afterward, when we want to report our density, which has already been calculated here, we have to also include its uncertainty. So the last part here shows us the density with its uncertainty. All right, so to calculate the uncertainty, it will not always going to be 0.1. Sometimes it's going to be higher or smaller than 1. So what happens actually, we have to follow this steps. First of all, we have to calculate the fractional error, and afterward we calculate its error by calculating the fractional error here, 0.0183. Hopefully you can see this, and then multiply with the density. So that is how you obtain the uncertainty of the density. All right, so if we take a look in the notes, I've also provided another example, and this one is actually for calculating the radius of a sphere, something like a ball shape. All right, so we have to calculate the radius, and then moving forward, as you can see, the question shows us the solution. First of all, we calculated the radius, and afterward to calculate fractional error, and then last but not least is to calculate the error or its uncertainty. So the final answer, as you can see, it is not going to be as simple as writing 0.1. So it goes through these steps in order to determine its uncertainty. All right, moving forward, it's the same as in our workbook here. So I'm going to change from PowerPoint slide to the workbook. Okay, so these are the two equations when you are asked to calculate percentage error or percentage difference. When we talk about percentage error, it is when we compare experimental to the theoretical. So experimental is something that you obtain through doing experiment. So the data that you obtain through experiment is experimental or approximate value. But when you calculate, normally this happens during tests as well as final examination, you are using the accepted or theoretical or actual value. So you have to use this first formula, and then when you compare between two experimental values, you have to use the second formula. So this one is actually for two data that is obtained through experiment. So moving on, the most important part of chapter 1, as mentioned, is conversion of unit. Okay, so when we have units, for example, to measure the length, it can be more than just meter, right? Which is in this case, given an example which is going to be in inch. So for example, the question asks you to measure what is 15 inch in a form of centimeter. So we have to know firstly the conversion. So the conversion here is 1 inch is equal to 2.54 cm. This will be provided, so you don't have to worry about the conversion. You don't have to memorize the conversion. Right? So we just use 15 inch, the given value, and then we multiply with, in this case, the one in the bigger box here is actually the conversion. So 1 inch is equal to 2.54 cm. So afterward, what you can see here is actually we can eliminate inch because we can treat the unit just like when we deal with algebraic quantities. All right, so inch divided by inch. So in the end, we're going to end up with cm. So what you have to do is multiply 15 times 2.54 divided by 1. It is equal to 38.1 meter. So now let's take a look at another tutorial question to help you understand further on conversion of unit. So we now going to take a look at tutorial question number in this case, we're going to take a look at tutorial question number 8, which is actually a lot easier compared to 6 and 7. So I'm going to use this tutorial question. Okay, tutorial question number 8. A rectangular building lot is 100 feet by 150 feet. Determine the area of this lot in meter square. Okay, so I'm going to place it here. So this is going to be the question. So one thing that is missing in order to solve the question here is because we don't know what is 1 meter to feet. So we're going to be using a simple Google search in order to know the conversion. But it should be provided to you in tests as well as in final examination. Again, you don't have to memorize the conversion. All right, so on the internet, what we're going to find is actually, because the question asks for the feet transformed to meter, so we're going to type in, so we're going to be using Google. All right, so afterward, we just put in feet. As you can see, the first suggestion, feet to meter, which is fitting to our question. So right, as you can see here, we have to change feet to meter square, the area. All right, so in this case, we have 1 foot is equal to 0.3048. So we're going to be using this. So I'm just going to copy this and put it inside of our slide. All right, so this is going to be the information that is required to solve the question. Again, this should be provided in test as well as final examination. So to imagine this, we can draw a rectangular building, which is not a square. It will have 2 sides longer than the other one. So imagine this is going to be the rectangular building lot. So this side is the same as this side. The vertical sides are 100 feet, same as the one at the right. And then we have the horizontal side, and then this one is longer, which is 150 feet. So the question asks you to determine the area. So area is simple. We just calculate the length with the width, or the other way around. So we just have to calculate 100 multiply with 15 feet. So this is the first step that I'm going to show you, and then after I'm going to show the second method in order to solve this question. So first of all, just calculate the area. Just directly calculate 100 feet multiply with, and in this case, the other side will be 150 feet. All right, so use your calculator, or you can actually calculate it straight away without calculator. So as you can see here, we have 100 multiplied with 150. It will be 150. And we had another 2 zeros here. We have 15,000 feet square. So it is important to know that, first of all, we calculate the numerical part, or the values, numerical or the numbers. So 100 multiply with 150, and another part is actually we have to multiply the unit. So actually what I did is I multiply feet multiply with feet, so it will be feet square. And if we multiply another feet, for example, in this case we have 3 feet or 3 dimension, it will be feet to the power of 3, or feet cube. All right, so this is our area. The problem being is actually we don't want it in feet square. We want it in meters square. So we have to change it to meter square. So this is another way, right? So area, I'm just going to write it again, 15,000 feet square, and then I'm going to multiply with the unit of conversion. So I'm going to write 0.3048 meter over 1 foot. However, as you can see here, we can eliminate only one of the feet, because here we have feet square. So we have to put in another conversion. So I'm going to put in another one, which is 0.3048 meter over 1 feet. So with that, we can actually eliminate both of the feet, or in this case, which is going to be the feet square. All right. So however, we have to multiply the value. In this case, we can just right away write down, firstly, when we want to solve the unit, now we have meter multiply with meter, so final answer should be in meter square. So what we have to do is multiply 15,000 with the first conversion, which is 0.3048, and then multiply with another conversion, again 0.3048. So you have to multiply it twice in order to obtain the final answer should be in 1393.55 meters square. Okay, so this is the first method, which is actually just calculate and afterward convert unit, and then obtain the final answer. Another way is we convert unit first and then we multiply to calculate the area. Okay, so this is the second method. So I'm just going to clear, all right? So I'm clearing this space. All right, so this is going to be the second method, which is, I would say, easier for you, but it takes a longer time, okay? Firstly, we have, again, the same question, and what we have to do is, firstly, write down the length, which is 100 feet, and then convert to meter. So what we have to do is multiply this conversion. We have to put foot and meter, and then in this case, we write down feet as the denominator because we want to eliminate these two. And then we put in 0.3048 meter, and then as you can see, we can eliminate because if you write this down in a single fraction form, we have 100 feet multiply with 0.3048 meter over 1 feet. So everything is placed together. So you can see straight away, we can eliminate firstly feet, and we're going to end up with meter. And then afterward, to make it clear for you, we can write down 100. Now it is just the number, and then multiply with 0.3048, and then over the denominator, which is 1, and then the unit is going to be in meter. So length, if you calculate 100 multiply with 0.3048, it is going to be 30.48 meter. So moving on, if this is the length and this probably be the width, so the width is going to be same method. So I'm just going to speed it up. So the width is going to be 45.72 meter. So to calculate the area, it is going to be L multiplied with the width. So we have 30.48 meter multiplied with 45.72 meter. So again, calculate the numbers. So we have 30.48 multiplied with 45.72. It is going to be the same as the previous answer, 1393.55. And then remember to multiply the unit as well. M multiply with M, it is going to be M squared. So this is our final answer. So there you go. We have two methods here, method 1 as well as method 2. All right, guys. Do you understand? All right, very good. Ryan. All right. So any questions so far?
No, sir, clear.
All right. Can I ask, Fahad, which country do you come from?
Sir, I'm from Pakistan.
Pakistan. Okay. If I'm mistaken, Pakistan use currency lira, is it? Currency.
Currency.
Oh, rupee.
Yeah.
All right. So let's say you want to convert Pakistani rupee to Malaysian ringgit. So 1 rupee is 0.025 Malaysian ringgit. So let's imagine. So I'm going to use this information. All right. So we're going to use what we have learned in our daily life. All right. So for example, we have imagined if you have a money, so let's say we have, in this case, we have, let's imagine 32 hundreds or 3,200 Pakistani rupee. All right, so okay, so the symbol will be RS. Okay, so RS, is it placed in front or at the back of the number?
At the
At the
front,
back,
front.
at the front. All right, so so I'm going to put in. Okay, I'm going to change the color. So let's imagine. Okay, so this is going to be RS 3,200, and we want to change it to Malaysian ringgit. So what we have to do is we just use the conversion. So we just put a bracket. This is a bracket, or sometimes it can also be called as the parentheses. So what happens is actually we're going to put the Pakistani rupee here, so RS1 below. Okay, because we want to eliminate RS, and then we put in Malaysian ringgit, which is RM. We put in 0.025. So what we have here is actually the same as in the previous example when we want to convert the unit. So RS can be eliminated. So we end up with RM. So afterward, when we calculate, what we're going to obtain is going to be just multiply 3,200 with 0.025.
80.
So 80, is it? All right, okay, it is going to be RM 80. Or obviously we can just use the conversion in the internet here, 3,200. All right, so it's around 80 Malaysian ringgit. All right, so that is how you convert unit using this method of conversion. All right, so if you have more than one, you just place it side by side. All right, just like this one, we have the first and the second. So for chapter 1, the most important part is going to be in the unit conversion. Okay, so now I'm going to proceed to vectors. So vectors for chapter 1 is not really that important, but it is important when we learn the next chapter, because vector will be used a lot in topic 2 and topic 3. Okay, so vectors is a way in order to report the direction of an object. All right, so an object cannot just be stationary It can also be in motion or moving, right? So with that, we're not going to have only the length, the mass, and for example, the time, as we learned topic 1. All right, so object can have length, and then object can have mass, and an object can also be placed at a specific time. So when object is actually moving, we're going to have, for example, distance, displacement, speed, velocity, as well as acceleration. And then because the object is in motion, so what happened is actually we have to also report its direction. So in order to report direction, we use vector. Okay, so in this case, we have two kind of quantities, which is going to be vector quantity. So vector quantity has both magnitude as well as direction, whereas the scalar quantity is only showing the magnitude or the size. All right, so with that, to show direction, we need a system. So the system here is actually the coordinate system, which I believe you already learned previously. All right, so in this case, for coordinate system, we're going to have two axes, which is going to be the x and the y axis. The x is also known as the horizontal axis, and then the y is going to be the vertical axis. All right, so if we have an object here placed at this position, we can just simply write down as x, y inside of this bracket. We start firstly with the horizontal distance away from the origin point, and then we have a comma here to separate between the two values, and then we have the y, which is the vertical distance again away from the origin point. Right, so another way, we have the plane polar coordinates. The plane polar coordinates is going to be very useful when you learn topic 4, when we are dealing with object that is rotating, just like the Earth that is rotating on its axis. Okay, it is moving in a circular motion, orbiting the sun. The Earth is orbiting the sun, and at the same time, it is also rotating on its axis. Right, so that is very useful when we learn about plane polar coordinate. So the plane polar coordinates, however, we still have the vertical as well as the horizontal axis. However, the information provided is going to be in the form of r as well as theta. All right, so firstly, Cartesian coordinate system, we have x and y. However, for plane polar coordinates, we have r and theta, where r will be the radius, straight or shortest distance from the origin, and then theta will be the angle between the r and a fixed axis. And then normally we use the positive x-axis, and then theta is measured counterclockwise from it. Okay, counterclockwise, it will be positive angle, and then if it is clockwise direction, it will be negative angle. So with that, we have to actually know how to convert from one coordinate system to the other, and we use this method, which is the trigonometry. And then in this case, if we take a look from our initial diagram here, we can create a triangle where we have the vertical side of the triangle given by y, and then the horizontal or the base of our triangle will be the x. So we can use these trigonometric functions, which is sine theta, cos theta, as well as tangent theta. So you can use all of these three according to the information given. Right, but normally we use tangent y over x. And then afterward, we can find the magnitude of r using Pythagoras theorem. Okay, and then for the Pythagoras theorem, the hypotenuse, which is the longest side of a triangle, is equal to the square root of x squared plus with y squared. Right, so let's take a look at an example here, which is example 1, and then we're going to solve the question. So this is the question for example 1. Again, for vectors, it is important when you learn the following topics, which is chapter 2 and 3. Okay, so we have this coordinate for 3, and then we have to change it to polar coordinates. And then this situation is asking you to transform x, y coordinates to r theta. Okay, so with that, we can imagine that this is creating a triangle. So this is our triangle. So to help you further understand, so I'm going to shade this. Right, so this is our triangle, the one shaded here. So our quest is actually finding what is r and what is theta. Okay, so based from the coordinates, what we have is this two information, which is 4 and 3. 4 will be the x distant or the x unit. Okay, the horizontal unit, meaning that there will be 4 scales here, and then for 3 it is actually for the y. So here it is going to be 3. So if we transfer this triangle, it can be in this form. So I'm drawing again the triangle. So we're going to have 4 here, and then this is going to be 3. And then we have to find the r as well as the theta. R is the hypotenuse and theta will be this angle. So what we have to do is we have to firstly find r. So remember the formula that we have to find r. Because it is the hypotenuse, we use this formula. Actually, the formula is r square is equal to x square plus with y square. Okay, so it is transformed to make it simpler for you. In this form, r is equal to square root x square plus with y square. But always remember that the original formula according to Pythagoras is the first line there. R square is equal to x square plus with y square. So now we can substitute. We have x, and then the x will be 4 squared plus with 3 squared. So this is a common value for right angle triangle, and the answer is going to be 5. Okay, so that is simple. And then moving on afterward, we have r, and then now we need to find the theta. So the theta, if you refer to the notes as in the workbook, theta, normally we use tangent. Theta is equal to the y over the x. So tangent meaning that it will be opposite over the adjacent. Right, so if we take a look from this angle, theta, opposite is going to be 3, and then adjacent is going to be 4, which is correctly the y and the x. This is the y, and then this is going to be the x. Right, so we can just write down tangent theta is equal to the y, which is 4 over 3, and then we have to, sorry, it is the other way around. Y should be 3. So I'm going to change the denominator here as well as the denominator. So again, y should be 3 over 4. So to find theta, we have to move tangent to the right side. So to do that, tangent will be an inverted tangent function, which is tan -1, and then 3 over 4. So theta can be radian or in degrees angle. So for simplification, we can just use degrees angle, which is equal to 36.87 degrees. But you can use radian as well to actually describe the angle. So afterward, we can now write the r theta. So write down your final answer. It should be in r and theta, so 5, and then 36.87 degrees. So this is our final answer. All right, so that is how you change from Cartesian to polar coordinates. Okay, so last but not least is going to be, as you can see in the workbook, last but not least, it is going to be the properties of vector. So vectors, as you can see here, can be moved from one to the other, and then it is still going to be equal vectors or the same vectors. So if we have an object moving, for example, let's imagine the object is moving from this left end to this top right end. So what happens is actually the same motion can be applied to other position as well, and then the vector is still going to be of same value. Because when we talk about vectors, it is actually the motion from initial position, which is here at the back of the vector, as well as to the final position, which is at the tip of the arrow. All right, so object is moving from here to here, initial to final. It is showing direction, which is vector. So what happens is that we can imagine it is moving roughly around 2 units to the right and then 2 units upward or above. So we can repeat that motion, all right? So to any other position as well. It is still moving 2 units to the right and then 2 units upward. Sorry, 1 unit upwards. All right, so regardless any position, the same vectors will show the same direction, even it is moved in any position inside of the Cartesian coordinates. All right, so when we add vectors, we can use mathematically as well as geometric method. So for example, if we have geometric method, let's imagine we have two vector, vector A and vector B. So let's say vector A is moving to the right, but vector B is a bit more complicated, meaning it is moving to the right as well as upward. So when we add vector A and B, we're going to have a resultant vector, which is vector R. So we can add this two ways. First of all, we can write it as A plus B. All right, we adding A plus B, so it is going to be A plus B. Or we can also write down B plus A. Regardless, we're still going to end up with the same vector R. So the same vector R is going to be the hypotenuse here, which is the longest side of the triangle. Okay, so in diagram A, we see that this is the longest side. Okay, this is the longest side. And then it is also showing the same vectors if we use B plus A. Okay, so that is actually under commutative law. So you can also use mathematical ways in order to solve this. And then when we have a negative vector, it is actually meaning that in this case, it is the opposite direction of the original vector. So let's imagine if we have vector B is moving upward, and then if we are asked to find A minus B, so B initially upward and rightward, now it is going to be downward and leftward, negative B. Right, so that is actually negative vectors. So when we talk about vectors, again, we are showing direction, meaning that it is moving, as you can see here, X unit to the right as well as Y unit upward. And it can also be leftward or downward. So when it is upward as well as rightward, as in this figure, both will be positive, meaning that AX is positive because it is to the right, and then AY will be positive because it is upward. But if it is leftward, it will be negative. And then if it is downward, it is also going to be negative. So as you can see here, both are positive because it is rightward as well as upward. All right, so moving on, we can write it in this form, which is given the X value, and then we have this unit vector, which is I, and then we also have J. Sometimes when we have a bit more difficult or advanced object, it will be in 3 dimension. So we not only have I and J, we also have another one which is K. The K is for the Z axis. All right, so with that, this is actually some of the question actually taken from previous semester tests. So we're gonna take a look at this question as our final question for today. And then this is actually taken from page 11 from the workbook, which is uploaded in the Moodle. You can download later on, or I hope that you already downloaded the workbook. You can also print it to make it easier for you to put in the answer later on. Okay, and then again, this is actual sample exam question. And then this one is in page 11, so you don't have to write down the question. It's already there in the Moodle. Okay, so with that, I'm going to copy the question and put it in the presentation here. The first one, and then afterward, we have the following question, which is just question number 2. Okay, so question number 2. So I'm going to put it again here in the presentation. It's different. It's the same for certain chapter, right? So Ryan is asking here, the book for previous subject, which is PHYD 114. In that syllabus for PHYD 114, we have 10 chapter. Ryan, okay, 10 chapter, but for this physics, we only have 8 chapter. Okay, so only 8 chapter, and then if we take a look at the tutorial question, previously, as you can see here, we only have 8 topic or 8 chapters. And then previously, when you learn PHYD 114, the final chapter are about electromagnetism. You learn a little bit about electric circuit. However, for PHYD 1013, you learn about thermodynamic. So that's why we have, for example, this temperature in degrees Celsius. So you learn about thermodynamics in PHYD 1013. So that's the different in the syllabus. Okay, so I hope you answered the I've answered the question. All right, so now I'm going to proceed to this question. Let's imagine we have a particle that undergoes the following consecutive displacement. So we have the motion of the particle 3.5 meter south, 8.2 meter northeast, and 15 meter west. So we have values and we have direction. So these are vectors, a total of 3 vectors. The first question asks you to sketch the vector diagram of the displacement, 3 marks, and then determine the resultant displacement of the particle. Okay, so first of all, it is important to know directions. So common directions are going to be north, south, and we have west and east. Okay, however, as we read further, we have south and west, which is in these basic 4 directions. But a bit more difficult here is actually we have northeast. So where is northeast? Northeast is actually right at the center in between north and east. So if we have north and east 90 degrees with one another, and then east is 90 degrees with south, they are 90 degrees with one another. When we talk about northeast, it is in the middle. So this is northeast, and the angle will be 45 degrees from east, and then again 45 degrees from north. So same goes to other direction as well, which are, we have southeast. All right, Malaysia is in Southeast Asia, so it is actually in this direction. We also has southwest, and then last but not least, we also have northwest. Again, the distance are 45 degrees from the basics for direction. Okay, so now we can actually draw or sketch the vector diagram of the displacement. So what I'm going to do is I'm going to put in the two axes, which is the x and the y. And then we're going to start firstly with the first vector. So for the first vector, I'm going to use green color, 3.5 meters south, meaning that moving downward. So roughly this is going to be the first vector. And afterward, we have 8.2 meter northeast. So a bit longer, more than twice. And then it is going to be 45 degrees. So the object is moving from origin point, which is here, moving 3.5 meters south, and then now it is moving 8.2 meter northeast. So this is going to be the second vector. And last but not least, it is going to be 15 meter west. So the last one I'm going to be using purple color. So 15 meter west, meaning that it is moving to the left. So this is going to be the vector. So it is almost twice as long as the previous one. So in order to draw vectors, it is important to draw not only the direction, which is in angle, as well as its magnitude, which is the length. So now we have the three vectors together. Okay, and then we have sketched the diagram, and then from the diagram, it is important to know what information that we can obtain. So what we can obtain is actually we know that the object is moving from the origin. A particle undergoes the following consecutive displacement: 3.5 meters south, 8.2 meter northeast, and then 50 meter west. So what happens is actually the object will eventually end at this position. So we can take these three paths, or we can just write down eventually this is going to be the final position. We have initial, I'm going to put it I here, initial, and then this is going to be the final. All right, so even though the object travels through these three paths, we can put the shortest distance, which is displacement, as the one in the red color. So the question asks you to determine the resultant displacement of the particle, which is the vectors in the red color. So firstly, I'm going to transform 3.5 meters south. So let's imagine this is going to be vector A, which is our first vector. I'm going to put it in this arrowhead form, A with the arrowhead. You can just put in arrow just like this one. And then because it is moving 3.5 south, remember that for X component, we use I cap. And then for Y component, we use J cap. So for this one, it is going to be J because it is going south or downward. And then afterward, we're going to put in the value 3.5. But because it is moving down, it is going to be negative. So moving on now to the second one, which is going to be 8.2 meter northeast. This one is a bit more complicated because it will have both X as well as the Y component because it is moving this amount to the right as well as moving this amount to the upward direction. So we can represent the original yellow vector here into two vectors, which is for the X as well as for the Y. To do that, we have to refer to our trigonometric function as mentioned in the workbook. So normally what we have to do is you can just follow this direction or this method. So B with the arrow head here, because B is a bit more advanced vector. We have both x and the y. So I'm just going to write bxi and then plus with byj. It will have both component. So normally, but it depends on the diagram as well. So normally for x component, we're going to be using cos theta, right? Because we know that this is going to be 45 degrees. So cos is adjacent over hypotenuse. So you have to look back at the trigonometric function and understand the function. So cos theta, and then in this case, we're going to put in the angle, which is going to be 45 degrees, and then put in I cap, and then plus with by, which is going to be the y component 8.2 sine 45 degrees g. All right, so that is how we find both component. For x we use cos, for y we use sine, and then we can just use your calculator to calculate the value. So it is going to be around, for simplification, I'm just going to write down 5.8i, and then it is going to be 5.8 G. So this is our second vector, and then last but not least, we are going to determine the third vector, which is 15 meter west. Because this is a single direction, basic direction, it is to the left. So let's say this is going to be vector C. So for vector C, it is going to be to the left, meaning that it will be negative. Right away, we can write down is negative. And then because it is horizontal, or along the x component, we're going to put I. And then we put in the magnitude, which is going to be 15 meter. All right, so these are the three vectors. And then in order to obtain the radius, sorry, the resultant vector. All right, so the resultant vector, which is the one in the red color, initial to final, is equal to addition of the three vectors. Okay, so we're going to have firstly our vector A, and then we're going to put in plus with vector B, and then last but not least plus with vector C. Okay, so I'm going to write down all of the vectors. So I hope you understand, even though I'm not using all of the three colors. So vector A, I'm going to write down negative 3.5 G, and I'm going to put in a bracket plus with vector B, which is 5.8 I, and then plus with 5.8 G. Last but not least will be vector C, which is plus with negative 15 I. So in order to solve this, it is important to know that vector should be in this case, in two unit vector, which is, as you can see, we have the J. All right, so there are two J's and then two I. So we have to solve this according to its component. So to solve it, firstly, I'm going to add 5.8 and then minus with 15i. I with I and then J with J. So 5.8 minus 15, it is going to be negative 9.2i. And then solve for J, which is highlighted by this yellow color, which is negative 3.5 plus with 5.8, it is going to be positive 2.3 J. So as you can see here, for the I, remember it is going to be for the X component. And then for the J, it will be for the Y component. So for the X, it is negative I, which is to the left. Right? So, and then positive, meaning that it is going to be for the Y. So it is going to be upward instead of downward. Okay, so as you can see here, it is upward 2.3 unit or 2.3 meter. So we can actually imagine the distance. It is going to be 9.2 meter to the left, moving to the left, and then we have 2.3 meter going upward. And then normally we're going to solve our question not until just the vector. We're going to find the magnitude, finding the magnitude, because our initial information here is given in magnitude and direction. So the magnitude is going to be, in this case, the modulus of the vector, or finding the magnitude. And the equation will be, it will be the x squared plus with the y squared. So now we're going to put in the x squared. It is going to be negative 9.2 square plus with 2.3 square. It is almost the same as the vector, which is exactly the same because we are finding the hypotenuse, the longest length of the triangle. So it is going to be 9.2 square plus with 2.3 square. So it is going to be 9.48 meter. And then to find the angle, we use tangent, theta. So for the formula, finding direction, it is going to be tangent theta is equal to y over x. For the y, we can write down, it is going to be, y will be 2.3, and then it is divided by the x component, which is negative 9.2. Just substitute the magnitude as well as the sign. And then for tangent here, it is going to be arc tangent, or tangent negative 1, 2.3 over negative 9.2. The angle will be negative 14.04 degrees. All right, so we have now our magnitude and directions. All right, so this is the magnitude and direction. So our magnitude is here. All right, so this is our magnitude, and then this is our direction. And then it is similar as the data provided, magnitude and direction. Same for the other three, the other two data. And then this should be our final answer. So whenever you solve this kind of question, this should be your final answer. And then we can write down, or we can actually interpret this data as the object or the particle here move 9.48 meter, and then direction, it is going to be 14.04, and then in this case it is north of west, right? Because it is moving away from the west direction, northward, because it is slightly above. So if I transfer the directions we have here, it is going to be west, and then this is going to be north, because it is moving away from the west. It is going to be written as, we can write down 14.04 degrees, and then in this case north of west. So coming from west, 14.04 degrees north, or we can write down as 14.04 degrees end of E. All right, so there you go. Chapter 1, we have finished all of the topic. And then what I want you to do is try to solve all of the tutorial questions in the given question here. You should be able to do question number 1 until question number 16. All right, so with that, Any question, student? Okay. Any question? I'm gonna ask. Firstly, I'm gonna ask Fahad. Do you understand?
Yes, sir. I understand. So far, so good.
All right. Okay. Very good. So whenever you have problem, you can actually view the video again, or you can ask question straight away in the WhatsApp group. Okay, so Ryan, I hope you also understood the lesson. Okay, so please make sure that all of you do tutorial question, and then later on, okay, I will give out quiz 1, which is related to chapter 1, which is in Moodle. Okay, so I guess that is all for today. Thank you, Fahad and Ryan. All right, and I'll see you in the next class. Okay, Assalamualaikum warahmatullahi wabarakatuh.
Walaikum assalam.